In the last activity, we saw how we could take a formula for converting Celsius and Fahrenheit temperatures and rearrange it into a different version of that formula. In this activity, we're going to look at other types of formulas and ways to rewrite those formulas. All right, so in order to do that, you have a couple things you need to do. The first thing is you want to know which variable you are solving for. Now, when we talk about solving for, this means the variable that's by itself on one side of the equation. For example, in this formula right here, there are 4 variables in that formula. The variable v, the variable L, the variable W, the variable H. And they all represent different things. V is the volume of a rectangular box. L is the length of that box, W is the width of that box, and H is the height of that box. This formula right now is solved for V, because V is by itself on one side of the equation. There's 3 other variables here, so we could solve for any of those 3 variables as well and write a different version of this formula. All right, so let's solve this equation for W. Solve for W. So what that means is we want to get W by itself. We want to get W by itself on one side of the equation. So currently the W is on the right-hand side of the equation. So in order to get the W isolated on the right-hand side of the equation, we need to eliminate L and H from the right-hand side of the equation. Since L and H are multiplied by W, we're going to undo that multiplication using division. So we're going to divide both sides by LH. On the right-hand side, the L's will reduce to 1. L divided by L is 1. H divided by H is 1. And 1 times W is just W. So we end up with the statement that V divided by length times height equals width. The volume divided by the product of the length and the height equals the width. And that is another formula that would also be valid and work for volume of a rectangular box. All right, so we're going to do the same formula. We're going to solve for H. All right, you give this one a try. Pause the video and solve for H. How did you do? Did you get volume divided by the product of length and width equals height? Hope so. Okay, let's go to number 2. The formula E equals Z times, that little thing is sigma. Let me write that down. This little guy is called sigma. I'm going to write it over here. Divided by the square root of n describes what is known as margin of error in statistics. If you take 146 statistics after this course, you will most likely be working with this formula. So we want to solve the equation for sigma. Okay, this one looks a little different. So we want to solve for sigma. We need to isolate sigma on the right-hand side of the equation. So we need to eliminate the z from the right-hand side of the equation and the square root of n. Now, since this is multiplied and divided, it really doesn't matter which one you do first. Remember, multiplication and division are pretty much equals except for the order in which you do them for the order of operations. We could actually rewrite this formula as just a multiplication, but let's just go ahead and well, maybe we should do that. If we think of this as z over 1, and we could combine this into one fraction, we would get z sigma over square root n. So you could think of this z over square root n actually as one value if you want to. But let's go ahead and just get rid of these one at a time. All right, so let's say we want to get rid of the square root of n. So it's being divided by the square root of n. So to eliminate the square root of n from the right-hand side, we're going to multiply. Multiplication undoes division. So now on the left-hand side, we'll have square root of n times e equals, and then on the right-hand side, we're just going to have z sigma, because these guys are going to reduce to 1. All right, so now we're still trying to get sigma by itself on the right-hand side, so we'll need to eliminate the z. Z is multiplied by sigma, so we're going to divide by z. Those z's will reduce to 1, and we'll be left with just sigma on the right-hand side, which is what we want. Sometimes when we have the square root of a number times another number, a lot of times we write the number that's not under the square root first, just to avoid any confusion about whether this e is under the square root. Like sometimes people get sloppy writing their square roots too long, and then it's like, is that e supposed to be under there or not? So if you put it in front, there's no confusion. But if you left it square root of n times z, as long as you're clear that it's only the n that's under the square root, that's perfectly fine. All right, I would like you to try to solve this equation for n. This one's a little trickier, but why don't you give it a try? See if you can isolate n on one side of the equation. Now, you could also use this version if you want. You could use this version of the formula, start from there and isolate n, however you want to do it. But I'm going to do it from the original equation. Pause the video, give it a try, and restart when you're done. Let's see how you did. Now, there's more than one way to do this, so this is just one way, but however you did it, you should get basically the same answer or an equivalent expression to this answer. The thing that makes this a little bit tricky is the n that we're solving for is in the denominator of a fraction. If you're solving for a variable, it needs to be in the numerator or a whole number, like that number over 1. So the first thing we really need to do, or one of the important things we need to do, is get this out of the denominator. So I accomplished that by multiplying both sides of the equation by the square root of n. Then these two square roots of n canceled on this side here, on the right side. So we were left with the square root of n times e equals z times sigma. Now I'm trying to get n by itself. Now the n isolated on the left-hand side of the equation. Now the n's on the left-hand side of the equation. So now I need to eliminate the e on the left-hand side. So to do that, we divide both sides by e, and we end up with this fraction, z times sigma over e. N is not by itself yet because it's got this square root over the top of it. What undoes square root? That's squaring. So we're going to square both sides. The square will undo the square root, and we'll be left with n equals the quantity z sigma over e squared. And that is the formula solved for n. Now I will say this particular example is probably one of the more difficult examples that we will do as far as solving for a variable. We're not going to get too much trickier than this one here, if at all. The next problem is a little more like most of the problems that we'll be doing as far as solving for a variable. And in Unit 4, we're going to be talking about linear equations. One such example of a linear equation is 4y minus 3x equals 20. It's not important right now if you understand what linear equation means. We're just highlighting what's coming and why the skill you're learning right now is going to be useful in the future. Right now, this formula has two variables, x and y, and it is not solved for either variable. If it was solved for x, it would say x equals, and then a bunch of stuff over here. If it was solved for y, it would say y equals, and then a bunch of stuff. It's not solved for any variable. So what we want to do in part A is we want to solve this equation for y. So we want to make it look something like this. We want it to say y equals, and then a bunch of stuff. So let's take a look. Our y variable is on the left-hand side of the equation right now. So we want to isolate that y. The first thing we're going to do is we are going to eliminate the 3x term from the left-hand side. So I'm going to add 3x to both sides of the equal sign. Negative 3x plus 3x is 0. 0 plus 4y is just 4y. So I have 4y on the left-hand side. On the right-hand side, these are not like terms. If you're thinking this is 23x, that is not true. It's not 23x. You'd have to have 20x plus 3x to get 23x. 20 and 3x are not like terms, so you literally cannot simplify it. you're just going to leave it as 20 plus 3x. The next thing we're going to do is we're going to eliminate the 4. It's 4 times y, so to eliminate that, we're going to divide both sides by 4. On the left-hand side, 4 divided by 4 is 1. 1 times y is y, so we just have y equals. Now on the right-hand side, we could just leave it like it is right there, 20 plus 3x all over 4. But remember, we're dividing everything here by 4, so a little nicer way to write it is going to be to divide each term by 4, to split that up. You're dividing every term by 4, so let's just do that. 20 divided by 4 is 5, and 3 divided by 4 is 0.75 or 3/4. For our work in Unit 4, it's going to be most of the time more beneficial to just leave this as a fraction and not a decimal. But a decimal would work as well. All right, I would like you to do the same thing, except I want you to solve this equation for x. Pause the video and restart it when you're done. Take a look. How did you do? Let's talk about this one. I'm trying to isolate x on the left-hand side. So the first thing I'm going to eliminate from the left-hand side is the term 4y. To do that, I subtract 4y from both sides. So that's going to leave me negative 3x on the left. So a couple things where I see students make little mistakes. This minus goes with this 3. You could actually think of this minus as plus a negative 3. So this negative needs to come down, or this minus needs to come down as a negative. So you're going to have negative 3x. On the right-hand side, these are not like terms, so we just have to write 20 minus 4y. Next thing we need to eliminate is the negative 3. Since it's negative 3 times x, we're going to divide both sides by negative 3. So on the left-hand side, negative 3 divided by negative 3 is positive 1. I have positive 1 times x, which is just x. On the right-hand side, I'm going to divide each of these terms by negative 3. 20 divided by negative 3 is negative 6 2/3. And then negative 4 divided by negative 3 is positive 4/3 y. So this is the answer solved for x. Let's look at number 4. The area A of a trapezoid with height h and bases, which are the parallel sides A and B, is given by this formula. Just so you know what this formula is talking about, so a trapezoid would be a shape like this. These sides have to be parallel. These other two sides don't have to be equal or anything. It's a four-sided figure. The height is the distance between the parallel lines. So you would measure this distance here at a right angle. That's going to be the height. And then the bases are the parallel sides. So these two sides are called the bases, and they are labeled with the variables a and b. And it doesn't matter which one is a and which one is b. So to find the area of this trapezoid, you're going to add sides a and b, divide by 2, and then multiply that result by the height, and you will have the area of that trapezoid. How many variables does this equation have? You got it? How many variables? And what are they? A, which stands for area, h, which is the height, a, which is one of the bases, and b, which is another base. So there's 4 variables right now in this formula. There will always be 4 variables in this formula. Okay, what variable is it solved for? Or is it? What variable is this equation currently solved for? Hopefully you said a. Right now that variable, this equation is solved for a. A equals. A is isolated on one side of the equal sign. So we could ask you to solve for h, to solve for a, or to solve for b. So in these two parts here, we're just going to ask you to solve for b and h. Let's give it a try. Let's do this one. A equals h times a plus b over 2. So here we're being asked to solve for b. We need to get b isolated on the right-hand side of the equation. Either side of the equation is going to work, but it's on the right-hand side, so generally we'll keep it there. I think the first thing that I would like to eliminate is this h. This is h times this whole quantity, so I can eliminate that h by dividing both sides by h. So that gives me a over h equals a plus b over 2. All right, we need to get b isolated. What should we get rid of next? Well, since the whole thing a plus b is divided by 2, like a grouping symbol, the next thing we're going to have to eliminate is the 2. Divided by 2. So to eliminate that, we're going to multiply by 2. On the left-hand side, then I'll have 2 times a over h. And on the right-hand side, I'll just have a plus b. All right, we're almost there. B is almost isolated. It's just a that's hanging around. So to get rid of a, we're going to subtract little a from both sides. And you can't really simplify this, so we're just going to, well, we're not going to simplify it. So you're just going to write 2a over h minus little a equals b, and that's perfect. There is a way to combine this into one fraction, but we're not going to worry about that, and that's fine. All right, you want to give b a try here to solve the equation for h? Why don't you give that a whirl, pause the video, and restart it when you're done. So this one may have been a little bit of a challenge to see, but what we have here is just h times this fraction, h times this fraction. So to get h by itself, I need to get rid of this fraction, a plus b over 2. And I can get rid of that fraction all at once by multiplying by the reciprocal of that fraction. So if I multiply by 2 over a plus b on both sides, these two fractions here, when I multiply these two fractions together, the result of that is 1, right? The a plus b's will reduce and the 2's will reduce, and you'll just be left with 1. So this will come out to be h times 1, which is just h. And now I have h isolated on the right-hand side. On the left-hand side, I could just leave it like this and copy it. A little nicer thing to do would be to multiply these fractions together. So put a over 1, capital A over 1, and multiply straight across. So I have 2 times capital A over little a plus b. And that's one fraction, which is a little bit nicer. Alrighty, last one. Let's give it a whirl. The volume of a right circular cone with radius r and height h is given by this formula here. So this formula has to do with a cone like this. Okay, and the radius is the radius of the circle, and then the height is the distance between the top of the cone and the center of the circle. So how many variables do we have in this formula? We have volume, radius, and height. Right now, this formula is solved for volume. So the only other variables we could solve for are radius and height, and that's exactly what we're going to do in part A and B. Let's tackle part A, which is solving for height. So we have 1/3 times pi, which is just a number, times r squared times height. And we want to isolate height. So we need to eliminate the 1/3, the pi, and the r squared. All of those are multiplied by h. So in order to get rid of all of these, in order to eliminate all of these values on the right-hand side, we are going to divide. You could do it one at a time, but why not just do it all at once? Let's just divide by all this stuff at one time. If I do that, 1/3 divided by 1/3 is 1, pi divided by pi is 1, r squared divided by r squared is 1, so we just end up with 1 times h, which is h, and on the left-hand side, we have v over 1/3 pi r squared. So if you knew the volume of a cone, or the volume you wanted, and you knew the radius, you could determine the height of the cone with those two pieces of information by plugging in values for v and r. All right, your turn. Solve this equation for r. Pause the video, give it a shot, and restart it when you're ready to check. So we're going to start this problem in a similar fashion as we did when we were solving for h. Here we're solving for r, so that means I need to eliminate the 1/3, the pi, and the h. All these values, 1/3, pi, and h, are multiplied by this r squared term. So in order to eliminate them from the right-hand side, I'm going to divide by all of those values. When I do that, they all reduce to 1, and now I end up with v divided by the quantity 1/3 pi rh equals r squared. R is still not quite by itself. It's not just r. We have this squared here. What undoes squaring? Good job, square root. My r kind of looks like a square root, doesn't it? We don't want that. Let's see if I can make it more like an r. There we go. So we're going to take the square root of both sides, and you might be thinking, oh my goodness, how do I deal with that thing on the left? That looks terrible. You just rewrite it. There's nothing really to simplify here. This is the formula. Square root of the quantity v over the quantity pi, 1/3 pi, h equals r. And that is it. And we are solved for r. So this is kind of neat. We're seeing how we can use our algebra skills, this idea of doing some operation on both sides of an equal sign, to manipulate formulas and create different versions of the same formula.